Welcome to another episode of the brand called You, a podcast and podcast show that brings you leadership lessons, knowledge, experience, and wisdom from thousands of successful individuals from around the world. I'm your host, Ashutosh Garg, and today I'm privileged to welcome a very senior and respected professor from Maine, USA, Professor Neil Comins. Professor Neil Comins, welcome to the show.
Thank you. It's an honor to be here.
Thank you. Neil is a professor of physics and astronomy at the University of Maine in USA. Given the amazing work that he has done over his life, understandably, he has been recognized, felicitated, and awarded several times, and he's a published author of several books and articles. So, Neil, before we come to astronomy and some of your books, a few questions for you. You began your academic journey in engineering physics at Cornell and eventually earned a PhD in astrophysics and general relativity in Wales. What first drew you towards astronomy and the cosmos?
Well, it's probably not the reason you might think. When I was a child, I was severely abused by my father.
Uh-huh.
My physical and emotional self-images were terrible. So when I went to university, I decided to see whether or not I really was, a worthy person.
Hmm.
And so I did many physical things. I became a pilot, a
Hmm.
skydiver. I sailed in the oceans. I even raced against Prince Charles
Hmm.
once. And I then, in the intellectual realm, I took so many courses at university that I finished in 3 years,
Hmm.
but I stayed on for a fourth year of graduate courses. And then I decided I was doing okay. But I needed something to finalize my self-image.
Hmm.
And I decided the hardest possible subject that I could take, that's what I wanted to take, and
Wow.
that was general relativity.
Wow.
So I got my PhD. I presented my work to Stephen Hawking.
Amazing.
And in 1983, punchline here, 1983, Subramanian Chandrasekhar
Oh,
earned
wow.
the Nobel Prize
Yeah.
in physics.
Yeah.
And in his 1983 lecture, he cited my work.
Amazing. Congratulations.
Thank you.
Incredible. But what an incredible journey you've had. And, I've met so many people, but not someone who decided I'm going to start the most difficult topic and then win so many accolades there. So tell me, Neil, what have been some of the most rewarding moments from your life as an educator and a communicator?
Okay. Well, one of them was creating the book genre, exploring what if questions. The Washington Post called it a new genre back in the day.
Hmm.
That was one of the very most rewarding things. Another was to have my first book, What If the Moon Didn't Exist,
Mm.
made into a theater show in Japan, a movie type on screens all around the audience
Mm.
that played for 17 years every day. So that was quite an
Amazing.
honor.
Yeah. Yeah.
And another was discovering the importance of addressing misconceptions in science
Mm.
uh, to my student audience and to the public. And there are lots and lots of, I've identified over 1,700
Wow.
science misconceptions. And finally, for this for this list, having my book "Discovering the Universe." It's a textbook
Yeah.
used in hundreds of universities and colleges around the world.
Wow. Wow. Let's now move on and talk about astronomy. And this is such a fascinating subject. The common human being, a common viewer and listener, knows about astronomy, is fascinated by it, but not too many people know about it. And therefore, my first question for you, Neil, what are the biggest misconceptions people have about how galaxies form and evolve?
Sure. Um, well, one of them is that the solar system is a galaxy.
Mm-hmm.
It's not.
Mm-hmm.
Uh, Another is that the Milky Way and the solar system are the same thing,
Mm-hmm.
which is related to the solar system being a galaxy. In our Milky Way, there are at least 100 billion stars like the sun.
Wow.
Another one is that the Milky Way is the only galaxy.
Hmm.
There are at least 2 trillion, with a T, trillion galaxies. Another galaxies are the largest groupings of objects in the universe.
Hmm.
Galaxies are clustered together, and clusters of galaxies are clustered together.
Hmm.
So uh, another is that galaxies only contain stars,
Yeah.
but there's a huge amount of interstellar gas and dust in the galaxies.
Hmm.
And another is that spiral arms. The Milky Way has spiral arms.
Hmm.
Are solid entities,
Hmm.
rigid things
Yeah.
rotating, but they're not. They're made of gas and dust and stars,
Hmm.
all orbiting around. Another is that the galaxies of formed at the beginning of the universe, the life of
Hmm.
the universe. They
Hmm.
didn't. The universe, the Milky Way galaxy, formed a billion years later.
Wow.
Um, and the our solar system is only 4.6 billion years old, whereas our galaxy is 13.6 billion years old. And I could go on, but I'll
Yeah.
stop there
No,
for a moment.
but given us a very interesting perspective. I mean, I didn't realize our Milky Way was almost 3 times older than our solar system. Thank you for telling
Right.
me this.
Yeah.
Uh, Neil, you've explored what life would be like in metal poor or older universes. How close are we to identifying planets that could support life in such unfamiliar conditions?
Oh, that's an interesting question. With the James Webb Space Telescope out there now, we are uh, able to study the chemistry
Hmm.
of planets. And we are beginning to discover chemicals uh, in the realms of other planets like dimethyl sulfide, um, which are typically created by life.
Hmm.
So if those gases are there, then maybe there's life that created the gases.
Hmm.
Dimethyl sulfide is created by algae, marine algae, for example. So I would say that we're within a few years,
Hmm.
a decade maybe.
Yeah. You think it could be as soon as that?
Yeah, I think so.
Hmm.
I
And
like to be optimistic.
I agree. And I'm going to come to the big thing that's happening on the three-eye atlas, where people say maybe there's life, but I'm going to reserve that for a little later in our conversation. Neil, you've spent years studying astronomy misconceptions, and you told me a few just now. Which misunderstanding is hardest to correct even among educated audiences?
Oh, the hardest misconceptions that I can think of are that the Big Bang began at one point in space. In other
Okay.
words, when people visualize the Big Bang, they think it was here and then you could watch it and it grew like
Yeah.
that, but
Yeah.
it didn't.
I did
The
not.
Big Bang created space
Hmm.
as well as matter and energy and time. So that's one of the hardest ones to correct.
Hmm.
Another is that the seasons are caused by changing distance from the sun.
Okay.
Intuitively, most people think
Yeah.
that when we're closest to the sun, it's
Sun.
hottest.
Yeah.
Right. And in fact, we're closest to the sun in December.
Okay.
It's it's
Okay.
the seasons are due to the tilt of the Earth's rotation axis.
I see.
And another is, and almost everyone is taught this, that the moon orbits the Earth
Hmm.
in the sense that if this is the Earth and this is the moon, the orbit of the moon is an ellipse
Hmm.
around
Hmm.
the Earth.
Hmm. Hmm.
And that's wrong.
Oh,
The, the two bodies are orbiting like this.
around each other.
Yes, actually, there is a central point, which is about 1,067 miles under the Earth's surface
Hmm.
in a straight line, not the center,
Hmm.
here. And as the two go around, they are going around that point.
Hmm. Wow.
So,
Wow. And I wanted to ask you a few other questions relating to, say, India. India has a
Sure.
rich legacy of astronomical thought. Which contributions from ancient India do you find most scientifically remarkable?
Great question. How about here are a few. The Earth orbits the sun.
Mm,
It used to be believed that everything orbited the Earth.
mhm,
Um, Another discovery by Indian astronomers is that the Earth rotates, spins
mm,
on its
mm,
axis.
mm,
And the shape of the orbits of the planets around the
mm,
sun are
mm,
ellipses,
mm,
egg-shaped, if you will.
mm,
And why do eclipses occur?
mm,
These were all discovered, identified by Indian astronomers. And interestingly, the concept of gravity,
mm,
Brahmagupta came up with this idea,
mm.
and it had not been around before the 7th century.
Wow. Amazing. Amazing. Modern observational astronomy in India is gaining global attention, Neil. How do you view India's role in today's astronomical research landscape?
I think the Indian contribution is astronomical,
Mm,
so to speak. So here are some of the things that India is doing right now. First
mm.
of all, there's space missions
Yeah,
run by the ISRO, Indian Space Research
research organ.
Organization.
Yeah,
It has 133 missions at present.
correct.
Um, Among them is orbiting the moon.
Mm,
And in 2008, that um, satellite discovered water on the moon.
mm, mm.
There's ice at the poles of the
Yeah.
moon. It also mapped the lunar surface.
Mm,
There is also in space an observatory of the sun, solar observatory,
mhm,
Aditya L1. L1 stands for Lagrange point. It's a place in space where the gravity of the Earth and the gravity of the sun balance each other, and the satellite stays there because it can't float away.
mm,
It's
mm,
pulled back by those two
mm,
bodies.
mm, mm,
Um, uh, there's a fascinating, in my realm of general relativity,
mhm,
research for gravitational radiation,
mhm,
gravity waves. And my thesis advisor led this for many years, but India is deeply involved. It's called LIGO,
mhm,
Laser Interferometer Gravity Observatory, Gravitational Radiation Observatory.
mhm.
And India is involved in that project, or it has its own, actually.
Right.
Uh, there's also a 30-meter telescope that is being planned to be put in Hawaii
Yeah.
on Mauna Kea.
Mm,
Um, and then Jayant Narlakar's
yeah.
work on cosmology is bringing us new insights all the time.
Mm,
Also, Indian astrophysicists are studying stellar evolution,
right.
black holes,
Mm,
and supernovas.
wow. And as telescopes like Hubble and James Webb redefine our understanding of the cosmos, what unanswered question in astronomy do you think we are closest to solving?
Do you want one or a few?
Give me a few.
All right.
Okay.
Are there any other planets in our solar system
Yeah.
besides the 8 we know of
Mm,
and Pluto?
yeah.
There may be planets out beyond Neptune
Mm-hmm.
that are so dim that we haven't been able to see them yet.
Mm-hmm.
So that's one of the things, and people are looking for them.
Mm-hmm.
Another related topic is in orbiting other stars. Are the planets orbiting, and we know there are planets, by the way, are the planets orbiting in similar orbits to what is going on in our solar system with our planets,
Mm-hmm.
or are they completely distributed differently?
Mm-hmm.
And how, if they're distributed differently, how would those different orbits affect the possibility of life? Because life would have to occur on a planet where the water can be liquid.
Mm-hmm.
And so that's a real issue. Um, a couple others. What is the nature of dark matter
Mm-hmm.
and dark energy?
Mm-hmm.
Dark matter is what provides the gravity that holds the Milky Way together.
Right.
Dark energy is what's pushing the universe out faster and faster all the time.
Mm. Mm. Amazing. Um, how do you see artificial intelligence accelerating discoveries in astronomy from data analysis to simulation modeling?
Absolutely. You covered it right there. Um, the data analysis sets, uh, AI can look for things like supernovas
Mm-hmm.
and exoplanets and things that are changing brightness. We
Mm-hmm.
call them transients, much, much faster than we can in any other way.
Yep.
And they can also look for things that have never been seen before.
Mm.
So, in other words, they have a list of the features that they should see out there. And if there's something that isn't in that list, they might discover it. And they can do it much, much, much faster
Mm.
than we can without them. Um, they also can do, as you said, large computer simulations
Mm.
of evolution of galaxies like the Milky Way,
Mm.
collisions of galaxies, things like that.
Mm.
And a third thought is that they can be much more efficient in controlling telescopes that are observing things
Mm.
because the telescopes can start to drift
Mm.
and AI can be much more aware of what's going on. And if it sees clouds, it can adjust things in similar appropriately and so on,
Mm.
more efficiently than any other way.
Wow, what a great response. Thank you. Uh, one more question, and then I want to come to your books. Uh, Neil, there's been a lot of discussion about this interstellar object, 3I Atlas.
Yes.
And I've been fascinated by astronomy because I spent 7, 8 years in aerospace. Not that I know too much about it, but I love to read or listen to podcasts about it. I wanted to ask you, this 3I Atlas has generated significant scientific interest. What does this interstellar body tell us about the nature of interstellar visitors, if any, and how might such objects reshape our understanding of the planetary systems beyond our own?
That's a question which I'm afraid the answer isn't going to be as exciting as you'd like.
I know.
First of all, I should say that 3I Atlas is the third object from outside our solar system
Mm.
to pass in close to the sun that we have been able to detect. There have been many more, of course,
Mm.
but this is only the third that we've detected. The chemistry that we've seen of its atmosphere, the gas is given off due to the heat from the
Mm.
sun,
Mm.
is very similar to the gases we see on comets that orbit the sun continuously.
Mm.
So those things are not providing insights into what's going on other stars. I
Mm.
might add parenthetically that that object, 3I Atlas, has been traveling in space so long that
Mm.
we have no idea what star it came from or
I
what
see.
star
Mm.
system it
Mm.
came from.
Mm.
Uh, Furthermore, I should add that there are no signatures of life in the emissions from
Mm.
that object.
Mm.
So we just, it's out there, it's interesting, but it's not telling us any profound insights into the
Okay.
evolution of
Obviously,
the.
obviously, you know, the social media is full of exciting stuff, and therefore I thought I had to ask you. But thank you so much for
No,
this
that's fine. No,
learning
it
for
is
me.
fine. They are finding, like water, ice and vapor and carbon monoxide and carbon dioxide, but they're the same as in the comets in
Correct,
our solar system.
correct, correct. Neil, I want to kind of come to your books now.
Hmm.
Your book, What If the Moon Didn't Exist, became a bestseller and inspired theater shows in Japan. What led you to explore these alternate universe scenarios?
Great question. The backstory of this is that when my son James was 3 years old,
Mm,
he was pointing to things all the time and saying, "What that? What that?"
mm.
Meaning, "What's that?"
Yeah, yeah.
And when he was 4 years old, the questions evolved from what that to why? Why,
Mm,
why, why?
mm, mm, mm.
Why is the sky blue? Why does the ball fall? Lots of, and there were some interesting
Yeah,
ones.
yeah.
When he was 5, he evolved the questions to what if questions.
Mm,
You know, what what if the sun was hotter?
mm,
What if, what if I hadn't fallen? Things like that. And when he was 5, a colleague of mine, David Batuski, walked into my office one
mm,
day and he said to me, you know, we astronomers are thinking about the cosmos too much the same,
mm,
which is really bad English, don't get me wrong.
mm,
But I said, I agreed with him and I said, okay, let's try to think of it differently. And
mm,
my son's what if questions came to mind.
mm,
And I grabbed the first what if question I could think of, which was, what if the moon didn't exist?
mm.
Dave and I kicked it around for a while. He had to leave and I was hooked. And it's been what if ever since.
Wow. Wow. I must get hold of a copy of this book and read it. Your next book was In What If the Earth Had Two Moons? Which scenario surprised even you when you first modeled it?
Um, that, that's an interesting question. I should add parenthetically that both of these books have 10 scenarios in them.
Okay.
And the one that intrigued me most is what if the Earth was a moon
Hmm.
of a larger planet, like
Hmm.
Jupiter?
Yeah.
What if Jupiter was orbiting where we are and we were orbiting Jupiter?
Hmm.
How would Earth be different? And the answer is profoundly.
Wow. Wow.
I,
Amazing.
I mean, I could obviously provide some of the insights, but I don't know how would
No, I
allow.
mean, give me one example, of
Yeah,
what would have
sure.
happened if Earth was a moon of Jupiter.
Okay. In that case, the gravitational pull of Jupiter on the Earth,
Hmm.
okay, would cause the Earth, which was spinning, who knows how it would be spinning, but the tidal force from Jupiter would cause the Earth's rotation to change so that the same side of the Earth always faced Jupiter.
Hmm.
So people who lived on Jupiter's side would always see that big object in the sky. People who lived on the other side would never see it.
Hmm.
And for example, you can imagine somebody wandering from one side to the other and seeing this big world for the first time.
Hmm. Hmm.
So
How
many
interesting.
possibilities.
How
Yeah,
interesting. I have time for two more questions for you, Neil.
sure.
Uh, Many readers say your speculative writing feels like science fiction grounded in real physics. What boundaries do you set between imagination and scientific accuracy?
The the boundary is literally what the science says. In other words, if science says that something is not possible,
Mm,
but one can express whatever that is,
mm,
that's science fiction. To the best of my knowledge, to the best of my effort, all of the information in my books
mm,
is based on science.
mhm,
So there isn't any way that I hope that those worlds couldn't exist,
mm,
but they presumably exist somewhere else. And the chances are very good that they all do.
mm,
So, so that's the separation. If everything I write about is based on hard science, I can actually do the equations, blah, blah,
mm,
blah,
mm,
to verify these things. And I do, and I
mm,
do. Um, but I do not include anything which is not scientifically possible, which is science fiction.
mm. So it's often said, and this is a very hypothetical question, but I've read a lot about it, is that somewhere in on some planet, in some part of the solar system, not our solar system, but somewhere in the Milky Way or the universe, there is another Earth in another time zone where there's another Professor Neil Comins and an Ashutosh Garg having an identical conversation. And I remember reading this as a science fiction sometime. Do you think that is within the realms of possibility at all?
No,
No.
I take it as pure science fiction.
Okay. Okay, thank you. And my last question for you, if you had to choose one more what if scenario for a future book, what would you like to explore?
It would be, what if life was discovered on Mars?
Mm,
That would be what I would most like to explore, because it's entirely possible it will be discovered on Mars.
mm,
And what kind of life would it be?
mm,
Would it be intelligent life, quote unquote?
mm,
I don't think so. But there are more fundamental kinds of life that could exist, for example, in underground oceans.
mm,
And what would be the consequences? For example, what would be the consequences of people migrating to Mars
mm,
and then interacting with these other forms of life which our bodies had never experienced
mm,
and never adapted to? Would they kill us off right away?
mm.
Would it change us, the people living there?
Yeah.
Those kinds of questions.
Mm. And I guess, if Mars is colonized, as Mr. Musk keeps saying, it will happen. A new evolution will happen to the human species to adapt to life there, and we may just have a different set of human beings with new life forms on another planet because we went and colonized. But on
Right.
that note, sorry, go ahead.
I was just going to add, just briefly, that for those people who are planning to go, one of my other books is The Traveler's Guide to Space.
Okay.
And The Hazards of Space Travel is even another book.
Mm.
So
Amazing,
there you
amazing.
go.
No, I'm sure my viewers and listeners would love to pick up your books because they get a perspective of how deeply you have thought about it. But on that note, Neil, I just want to say what a fascinating conversation this has been. From the time you decided to get into this, from the time you were very, very young and why you chose it, to talking about your son who decided to, point you in the direction of what if and how you took it forward. Thank you for speaking to me about so many different aspects of astronomy. I could just keep on learning and listening to you because you know so much. But I will reach out to you maybe in a few months and ask for another podcast, or maybe on another subject on astronomy because it fascinates me. Thank you for speaking to me, sir, and all the very best to you.
Thank you. It's been my pleasure. Great talking to you, Ash.
Thank you. Thank you for listening to the brand called You Videocast and Podcast, a platform that brings you knowledge, experience, and wisdom of hundreds of successful individuals from around the world. Do visit our website www.tbcy.in to watch and listen to the stories of many more individuals. You can also follow us on YouTube, Facebook, Instagram, and Twitter. Just search for the brand called You.